So for the past 2 days, we've been talking about box and whisker plots. Today, we're still going to be talking about box and whisker plots, but specifically how to interpret and read the story that they're trying to tell us. Today's May 10th. Stop. So, box and whisker plots help us visualize data by dividing that data into quartiles. Quartiles meaning quarters. We cut the data up into 4 equal-sized pieces. Each section of the box and whisker plot contains exactly 25% of the data. Which kind of feels counterintuitive considering if you look at the box plot for that first one, you've got this really long whisker in this longer piece of the box and then this shorter piece of the box and then the short whisker. But each of those pieces all contains 25% of the data. And that is because the width of each section is there to represent the variation of the data. And not the size of the data. That's probably the most common misconception about box and whisker plots, is that the longer parts have more people in it. That's not true. So let's look at an example that has 28 English 2 EOC scores. So first few questions, super easy. What was the highest score on the test? 100. What about the lowest score? Ooh, hold on. Looking at the gaps between these tick marks, we've got 0, blank, 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 20. It looks like it's counting up by 5s. So the lowest score looks like 5. Ooh, how about the median score? Where do you see the median on a box and whisker plot? The middle of what? The middle of the box. And y'all are right, it's 75. This right here is your median.
How many questions are on the ESV?
So, questions D and E switch from just what was to what percent of. So when we're talking about percents, remember, each of those pieces of the box and whisker plot is a quarter of the data, 25%. So, what percent of students scored a 60 or better? 75%. If you hide people who scored less than a 60, you've got this part of the box, this part, and this part. That totals to 75%. Okay. What percent of students scored between an 85 and a 100? 25%. That's just this upper right whisker.
Subs, this looks easier than yesterday.
Any questions so far, y'all? Okay, questions F and G are both asking how many students. So it's not asking for a percent, but we do need to know what the percents are. So F says how many students scored a 75 or higher on the test? How'd you get 14?
That's 25 divided by 8, it's 50%.
Okay, perfect. So going back up here, there were 28 students. And so if we're talking about a 75 or higher, that's the median or above, right? Well, that would be 50% of the scores. So 50% of 28 is 14. There were 14 students who scored a 75 or higher. And that should make sense because the definition of a median is the point where half the scores are higher and half the scores are lower. Sound okay? Okay, how many students failed the test? What's a failing grade? Below a 60. So it looks like this. 25%, which is how many students? 7. 25% of 28 is 7. Okay, I didn't word this question the best. What it says is, what is the range of the middle 50% of scores? In other words, the IQR. So an example of what I'm talking about here, in a few years you're going to take the ACT, right? And you use that ACT score for college entrances. And one of the metrics that colleges will tell you, they'll tell you like what's the cost and how many people go to school there. They will also tell you the middle 50% of ACT scores. It's a range, like the 25 percentile group had this score up to the 75 percentile group. And so if you fall in that range, you're going to be good.
So 60 to like 85.
Yes, that's what I'm talking about. The range of the middle 50% is just this box. It goes from 60 all the way up to 85. Which gives you an IQR of 25. And all I was really looking for there is for you to identify Q1 and Q3, which tells you the IQR. Okay, a few more deeper comprehension questions. And this next one is really just an opinion question more than anything else. Based on the data, would you say that this looks like an easy test or a hard test? I want you to take a minute, write something down. Again, take a minute and write down your opinion. Based on this information, does this look like an easy test or a hard test? Okay, show of hands, raise your hand if you think that this test was a hard test. Okay, show of hands, raise your hand if you think it was an easy test. Anybody have like a third option? What you think?
Both.
Hard and easy?
Like, I think it was like an average test. Like it was both kind of easy and both kind of hard.
Half the class failed or almost failed.
Okay, so some things that I can point out here is that a quarter of the class did fail the test. So that doesn't feel like a lot, but like from my perspective as a teacher, if I had a quarter of my class fail a test, I would feel kind of like, oh, was that too hard? Right? Like one kid who failed, if that's the kid who's like never here and always asleep, yeah, fine, whatever, that's going to happen. But like if a quarter of the class fails, that feels a little off, right? But then on the other hand, you did have 3/4 of the class who passed. So I don't know, it's kind of a hard question to answer. So, it's kind of a hard question to answer, so I'm just going to leave it at that. A quarter failed, 3/4 passed. Okay, Jay, not an opinion question. This is a question that we can definitely put an answer to. Are there any scores that are an outlier, and how do you know?
Could there be two?
Maybe.
5%.
How did we figure out if something was an outlier yesterday?
Like the big line? Far away.
Okay, so looking at this box and whisker plot, yeah, that whisker is really long, which says, feels like there might be an outlier down here at the 5. But there's a formula that we used yesterday. In fact, there are 2 of them. Let's go ahead and use that formula twice to calculate the lower and upper limit for what's considered normal. Remember, those are called fences. So, the lower fence. That formula is Q1 minus 1.5 times the IQR. The upper fence is Q3 plus 1.5 times the IQR. Well, all the numbers that we need for those formulas are up here in number 8, or excuse me, H. So for the lower fence, Q1 is 60 minus 1.5 times the IQR is 25. For the upper fence, 85 plus the same thing. So 60 minus 1.5 times the IQR gives you 22.5. 85 plus 1.5 times the IQR gives us 122.5. So, is there an outlier? Yes, why? Do we have any scores above 122.5? No. Do we have any scores below 22.5? Yeah, we have at least one of them. So we know that the 5 down here is definitely an outlier because it's beyond that fence. Here's where 22.5 would be. So the score of 5 is definitely an outlier. Are there more outliers? That's actually a trick question. It's impossible to answer that. Because we've just got the box plot, we don't have the raw data, we have no idea if all of those low failing scores were like in the 40s and 50s and then that 1-5, or if there was like people who made a 5 and a 10 and a 15. All of those would have been outliers, but there's no way of knowing that. We just know that there's at least one outlier in 5. Okay, last question, true or false? More students failed the test than passed the test. What do you think? Failing the test is all of this. Passing the test is all of this. That's definitely longer, right?
It's only 25%.
You're right. It's a trick question. There's only 25% that failed the test. Even though that whisker is super long, that doesn't mean there were more people who failed it. That just means that there's a higher variation in the failing scores. Again, only a quarter failed and 3/4 passed. again, only a quarter failed, and the width is just indicating a lot of variation in those failing scores. Can I get a scale of 1 to 5 how we're feeling so far? Okay. We okay to flip over to the back? Okay, on the back we've got a double box plot, or double box and whisker plot, that represents the EOC scores for the exact same group of 320 students from when they took the Math 1 EOC their freshman year, and the Math 3 EOC 2 years later in their junior year. Hang on just a sec. So, the top bar is representing all the Math 3 scores. Bottom bar is representing all the Math 1 scores.
You have to take the ESC every single year in
No.
high school?
So your only EOC classes are Math 1, Math 3, English 2, and Biology. There's no history or social studies EOCs right now. I don't know if that'll change in the future. And then there's just a couple more state tests for the CTE classes.
Is biology like a required class?
Yes.
Would the smaller whisker on Math 3 and Math 1, would that be considered like 25%?
Okay, that's a great question. So, 25% is each of these pieces. This low whisker on the Math 3 is 25% of the Math 3 scores. This really wide part of the box is still 25% of the Math 3 scores. 25% of the Math 3 scores are here, and 25 are scrunched up here. Same thing is true for the Math 1 scores. There's a quarter of the data on this whisker, a quarter in this part of the box, a quarter in this part of the box, and a quarter on this whisker. So A says, what was the highest score on the Math 3 test? 85. What about the highest score on the Math 1 test? 70.
That's another question.
Is it about these box and whisker plots?
Yes, kind of. What happens if we fail the ESC?
You got any plans this summer?
Yeah.
Oh.
Summer school.
Are you serious?
We can talk about that what if
What's a
scenario
what's
later.
a failing grade on the EOC?
Failing.
Like a 59 and below?
Yeah. Y'all, we'll talk about all those what if scenarios another time, okay?
Yeah, I'm gonna die. I'm gonna have some.
You'll be fine. Y'all, you will be fine.
If you pass the class, I have.
Yeah, that's what I'm wondering. What if you pass the class? And you
Okay, remember when I said we're going to talk about these what if scenarios another time?
We'll talk about them after this.
Besties, we're going to talk about it later, okay? My
After
friends.
This, right?
After this, we can talk about it.
Alright, bet.
Sound okay?
Yeah.
Cool. C and D are asking for percents. What percent of students pass the Math 3 EOC? Passing is a 60 or better, right? What percent of Math 3 passed? 50%. Next question says, what percent of the Math 1 people passed the test? Only 25%. I bet that doesn't feel good hearing that, considering we were just talking about what if we fail. Huh. It's a good thing that I just made up these numbers. Does that make you feel a little bit better? Okay, cool. E and F are saying how many students scored, so for E, how many students scored an 80 or better on the Math 3 EOC? Okay, so 80 or better is just this top whisker. How many people is in that whisker? 25%, which is how many people? 80? Why do you say 80? Yeah, 25% of 320 students is 80. Okay, how many students failed the Math 3 EOC? So, half failed. Half of 320 is 160. Okay, G. A little bit of an opinion question. Based on the data, which test appears to be harder? Take a minute and write something down. So, what are we thinking? Raise your hand if you think the Math 3 test was harder. Raise your hand if you think the Math 1 test was harder. Anybody got a third answer? Okay, so most everybody said that the Math 1 test was harder. I think that's a pretty fair statement.
75% failed.
That's a little scary.
I've heard because 75% failed. Any other reasons?
Oh, half or 50% of people passed the country.
Yeah. I mean, yeah, that's pretty cut and dry. Yeah, one thing about the Math 3 test, you know how in the Math 1 test there's no calculator for part of it? The Math 3 you get the calculator the entire time. There's no calculator part for that one. So that's nice. But you gotta wait till you're junior to get that. Okay, H, true or false? More students took the Math 3 EOC than the Math 1 EOC. How do you know? I mean, that Math 3 box plot is a lot wider than the Math 1 box plot. The question is, more students took the Math 3 EOC than the Math 1 EOC. And I'm saying that because, look, this box plot is way longer than this one. Okay.
It's still the same, but less people got far out there. It's still the same number, it's just people have better scores.
Going back up here, it says, the following box plot represents the EOC scores from the exact same group of 320 students. So, it's the same on both.
It's just smaller.
All you gotta do for that one is just read it.
I'm going to keep on writing. The Math 3 box plot is wider because... Someone help me fill in the rest of that sentence. The Math 3 box plot is wider because what?
No more variations with the grade.
Hey, very nice. Because the grades are more spread out. I mean, at the very least, looking at this box plot, the lowest score on the Math 1 test was only a 15, but the lowest score on the Math 3 test was a 5. The highest score on the Math 1 test was a 70, and the highest score on the Math 3 test was an 85. The Math 3 test just goes further in both directions. That's really why it's wider. And then definitely the 25 to 50% range, there's a lot of variation in this part, whereas the 25 to 50% range here for the Math 1 test, it's all pretty scrunched together. That sound okay? Okay, I. Based on the box plot, which test would you estimate has a higher average score, meaning the mean, and why? I mean, we've already said the Math 1 test is harder, so which one do you think has a higher average? The Math 3 test. Okay, so I've written the Math 3 test probably has a higher mean, higher average score, because from a box plot, can we tell what the mean is? No. The 5-number summary doesn't include the mean. You don't plot the average on a box and whisker plot. Is there anything about these box plots that could give us a hint as to whether or not the mean is higher or lower for one of them? Do what?
The biggest part of the box.
Okay. I'm going to draw 2 dots and see if that gives you a hint as to what I'm talking about or thinking about. What do those 2 dots represent?
That'd be like 25%.
Do what? The halfway point, the median. Okay, the median for the Math 3 is 60. The median for the Math 1 is 40. Now, we don't know the mean, but the mean is a measure of center, and another measure of center is the median. And they tend to be close within a little bit of each other, unless there's a crazy outlier. And I didn't ask it, but there's no outlier here. I'll just go and tell you. So, because the median of Math 3 is 20 points higher. Now I'm writing, because the median of Math 3 is 20 points higher, it could be a good indicator of the mean. Probably. Because again, we do not know what the mean is. We're just making a best guess that we can here based on the fact that the middle 50% of students here is above the middle 50% here. Okay, last one. This is an opinion question again, so it's really up to you. A student scored a 40 on the Math 1 EOC. That same student, 2 years later, scored a 60 on the Math 3 EOC. So both times, this student scored the exact median grade amongst their peers. In your opinion, did the student perform better or the same? Why do you think this way, and validate your opinion with the data? Take a minute and think, and then write something down. So here's what I wrote. On an individual level, that student definitely did do better. They grew by 20 points. Their score went from a 40 up to a 60. Their Math 1 EOC, they failed. Their Math 3 EOC, they passed. That is growth. But if you're thinking on a class rank level, they're still in the dead center. The median is still the median either way. They're still better than half and worse than half of their class. So it kind of goes both ways. Any questions, y'all? Please go and put your name and today's date on this new paper because you are going to turn it in. So, number one, the box plot below shows data collected on the yearly household income from 400 families in the school district. First off, what do each of these tick marks represent? How much? How much is these going up by? 4. It goes 0, 4, 8, 12, 16, 20, 22, 24, 30, 22, 20. Let me try that again. 20, 24, 28, 32, 36, 40. 44, yeah, and so on. So each of these is 4.
Hello?
Okay. Down here, the ACT scores. Hey, we just talked about that. Interesting. What are each of these tick marks? What's the scale? Just 1. G says, would a student who achieved a perfect score of 36 be considered an outlier relative to this data? If you're talking about outliers, you need to talk about fences. So you're going to need to talk about the upper fence formula. I'm going to go ahead and write it down. So if you hadn't already, write that down for G on number 2.
So, say upper fence.
It says upper fence Q3 plus 1.5 times the IQR. That's the formula that you need to be able to answer G. On the back, we've got a dog food store, or excuse me, a food store. What do each of these tick marks represent? What's the scale?
About
5 this time.
5.
Okay, this is representing how many pallets of dog or cat food this person ordered every week over the period of 1 year. How many weeks are in a year?
52.
52 weeks, very nice. So if you're talking about 25% of a year, that would be 13 weeks. Half a year would be 26 weeks. 3/4 would be 39 weeks, and so on. Let's see. Again, G is asking for outliers. You're going to have to talk about the fences here. Here, you're going to want to talk about the lower fence. The formula is Q1 minus 1.5 times the IQR. And then H, you actually have to do some math there. Multiply the highest sized order of dog food by the price, the highest sized order of cat food by that price, and then compare the difference. Any questions, y'all? Okay. You're welcome to work with a partner, move around the room. Make sure you're actually working.
Big